Hey guys, and welcome back to another video. For this video, I will be going over the 4-point problems for the Math Kangaroo 2017 test for levels 1 and 2. And let's get started with number 9. In the country of jewelries, you can trade 3 sapphires for 1 ruby, picture 1. For 1 sapphire, you can get 2 flowers, picture 2. How many flowers can you get for 2 rubies? So we can label rubies as R and sapphires as S, and flowers as F. So it's asking for how many flowers you can get for 2 rubies. So first let's see how many sapphires you can get for 2 rubies. So 2R equals how many sapphires? Well, if 1 ruby equals 3 sapphires, then that means 2 rubies will equal 6 sapphires. If 1 sapphire equals 2 flowers, then that means 6 sapphires will equal 12 flowers. So 2 rubies equals 6 sapphires equals 12 flowers. So we can see that it's not just 2 rubies equals 6 sapphires and 6 sapphires equals 12 flowers. Any of these equals any of the other ones. So that means 2 rubies also equals 12 flowers. So the answer for number 9 is D. Number 10. At one point, Jim and Ben sat on the Ferris wheel as shown in the picture to the left. The Ferris wheel turned, moving Ben to the place where Jim was previously. At that moment, where was Jim? So, Ben moved over here. So, I'm not sure which direction the Ferris wheel is moving, but let's assume it's going this way because that's the closer, and it actually doesn't matter which way it's going, the answer shall remain the same. So Ben reaches here, and you can see he goes through 1 and 2 intervals. So we have to move Jim somewhere, but making sure he only crosses 2 intervals. So here we have 1 interval and 2 intervals. So Jim will reach from here to here. So that means that the picture has to have Jim over here. So we can see that picture that has Jim over here is A. Number 11, how many triangles are there in the picture on the right? So let's count up the triangles that are there individually. We have 1, 2, 3, 4, 5, 6, 7. Now, we also have this large triangle that is formed out of triangles 1 through 4. So I'm just going to draw a line like this to indicate 8. Next, we have this triangle over here, which is triangle 9. This triangle over here. So we have an end of like this one. And then we also have this one. So that would be triangle 10. They're different, by the way. And finally, we have triangle 11 right over here. So this quadrilateral is actually used to make, with this 6th triangle, to become the last triangle 11. So as we can see, the number of triangles for number 11 is 11, which is D. So on to number 12. Alfred was turning a shape. The first 3 turns are shown in the picture. He did 6 turns in total. How does the shape look at the end? So we see 1, 2, 3, and then the 4th turn would actually make it look back here. So we can put a 4, then 5, then finally 6. And we can see 6 turns. And so we see this is the shape that will be at the 6th turn. And this shape matches either D or E because they look the same, but you have to notice the color. So You see here, blue is down here, and it's not even the right area. Here's the right area, which has peach like it is supposed to, and then blue here. So E is correct, not D. On to 13. In which pictures are there twice as many apples as carrots and twice as many carrots as pears? So here, let's first see apples and carrots. So in A, there are 2 apples and 4 carrots. And we can see that since carrots are more than apples, it's already a no, because apples have to be more if it's twice as many as the carrots. So A is a no. B. B has 5 apples and 3 carrots. Let's make these carrots twice. So 3 times 2, we get 6. As we can see, 6 is not equal to 5, so can't be B. Now, in C, there are once again 5 apples, and instead of 3 carrots, there are 4 carrots. So now when we multiply 4 times 2, we get 8. And so 8 is not equal to 5, so once again, no for C. D. D has 4 apples and 2 carrots. When we multiply 2 times 2, we get 4. So yes, it is finally equal, but we have to check pairs. So there are twice as many carrots as pears. Now we see there are 1 pair, so if we multiply 2 times 1, we get 2, which is equal to the amount of carrots. So we can see the answer for number 13 is D. Number 14. Brian and William are standing in line. Brian knows there are 7 people in front of him. William knows that there are a total of 11 people in the line. If Brian is just in front of William, how many people in the line are behind William? So there are 11 in total, and we have to subtract 7, because that's how many people are in front of Brian, plus 1 for Brian, plus 1 for William. After we solve, we get that this is equal to 11 minus 9. Whoa, that's a weird 9. 11 minus 9, which is equal to 2. So the answer for number 14 is A. Number 15. The ancient Romans used Roman numerals. We still use them today. Here are some examples. I equals 1, 2I equals 2, V equals 5, IX equals 9, X equals 10, XI equals 11, XX equals 20. This year we celebrate Math Kangaroo number XX. What year was Math Kangaroo number XV? So, as we can see, XX equals 20. So, right now we celebrate Math Kangaroo year 20. And here it asks what year was Math Kangaroo number XV, and XV is equal to 15. How do I know that? Well, X is 10. So, 10 plus V, which is 5, equals 15. So, to find how many years we have to subtract from whatever year it is now, we have to subtract 20 minus 15, and we get 5. So 5 years from this year, we will get Math Kangaroo number XV, but we don't subtract 5 from 2021, but we subtract 5 from 2017, because that's the year this test was created, so that's the year we're going to use for this problem. So 2017 minus 5 equals 2012. So the answer for number 15 is C. Even if you were to use 2021, you'd eventually find out that 2021 minus 5 is 2016. So 2016 is not an option, ruling out 2021. The only other number that would come to your realization is 2017, which is the test paper year. Number 16, last 4-point problem. Liz is making crowns like this, using the following stickers: a plus, a circle, and a line. There are 2 types of sticker sheets shown on the right. So they don't consider this 1 sheet, but they consider it 2. if she wants to make 3 crowns, what is the smallest number of sheets that she will use? So, for the first circle, for the first crown, 4 circles, 1 plus, and 1 line. So 2 sheets already used. So 1 crown equals 2 sheets. Now, 2 crowns. She will have to use 1 line, 1 plus, and now 1, 2, and we can see that we are short of circles. So we're going to have to get a third sheet, and we're going to get a third of this because it has more circles. So red will be pretending that we got another one. So cross out 2 more. So 2 crowns need 3 sheets. So now for the third crown, we will need 4 circles, and as we can see, we have these ones that are not crossed out with red. But we will need another one set of lines. And remember, we only had an extra this sheet. So as we can see, I've crossed this out, meaning that I had to get another one of these. So 3 crowns will need 4 sheets. But let's double check here, and then we see that we haven't touched this, so we can use this. Because the reason I didn't mark this one with red is because red is the ones that are being used twice, but this one is only being used once, so I don't need to mark it with red. So as we can see, 3 crowns equals 4 sheets, so the answer for number 16 is B. Why I underlined 2 was because they might have considered this as 1 sheet and marked the answer as 2 or something, but as you can see, they consider this as 2 types, so you have to actually have it as 4. So that's why the answer for number 16 is B, and that's the end of the 4-point problems. So please like, subscribe, hit the notification button, and keep on watching, because the test is near, and I just posted a video talking about when you will be taking your test depending on your grade. So go check that out, and bye!